I'm Kaitlin Keegan. I'm a PhD student in the labs of Ian Baker and Mary Albert at the Thayer School of Engineering at Dartmouth College, and I'm an IGERT Fellow. I study Firn, which is old snow on the top of the Greenland Ice Sheet. And in our lab, we're studying how snow that falls on top of the ice sheet undergoes compaction and densification and records climate information that gets trapped in the ice. Snow that falls on top of the ice sheet doesn't immediately become ice because snow in these regions of the ice sheet rarely melt during a summer season. Instead, snow becomes ice by undergoing densification from the overburden pressure of snow accumulating on top of it from successive snowfalls. This process creates a zone at the top of the ice sheet called the Firn column, which is comprised of snow that has fallen this year, as well as layers of firn that have fallen over about the past 200 years, and this zone lasts for 80 meters. Because the Firn column is made up of layers of snow and firn that have not yet reached the density of ice, there is an interconnected pore space lasting from the surface all the way to the bottom of the Firn column, in which air from the surface can blow through. When the firn at the bottom of the Firn column becomes ice, it traps a bubble of air. And since air from the surface can flow through the interconnected pore space from the surface to the bottom of the Firn column, the ice layer traps a sample of air that's close to present day. Whereas the ice that's forming the ice layer fell as snow 200 years ago. This creates an age difference between the air trapped in the air bubble and the ice surrounding it. It's easy to know the age of the ice layer because we can count back layers in the firn and ice just like tree rings. But it's hard to know the age of the air trapped in the air bubble. My research is generally aimed at understanding how long it takes air from the surface of the ice sheet to flow through the pore space and reach the bottom of the Firn column and get trapped in the ice layers. I look at this process in one place, in Nîmes, Greenland, where we went in 2009 and collected firn samples. When we analyze those samples back in the lab in New Hampshire, the first way I look at them is by measuring the permeability. Permeability is a measure of how easy or hard it is to have air flow through the pore space of the firn sample. And this gives us an understanding of how easy or hard it is for air to flow through the different parts of the Firn column. The second way I look at the firn samples is using a micro-CT scanner. The micro-CT images allow us to look at the structure of the firn and pore space and relate that to the permeability of the firn in those areas. The final way I analyze the firn samples is by carefully looking at all the layers in our 80 meters of firn core. In these layers, I can see differences in density and grain size, and even 2 melt layers. And all of these things tell us about how the surface of the ice sheet was in the past. My hope is that the permeability, micro-CT, and layer data will help us to understand how the air flows through the pore space of the Firn column and allow us to model the age of the air in the bubbles better. This will allow us to interpret the timing of past climate events in the ice core record with finer resolution.